There's a lot of talk in the marketplace about automatic or dynamic scaling. How does your solution compare?
So there's a number of different ways where you can do automatic or dynamic scaling. The largest difficulty with systems that are actually able to increase or decrease the number of devices that are providing a particular service is that they run into something called a cascading bottleneck. What this means is that they're only reacting to the load that's on a particular layer within an application. And most applications exist as multiple layers, such as the presentation layer, the application layer, the database layer, and additional applications that it's connected to. Now what this means is that when load hits something like the presentation layer, the system doesn't automatically scale up the layers underneath of that or the services that it's dependent on until that load cascades through the environment. Now, from a reactive perspective, what our system is capable of doing is it actually automatically generates the correlation between a particular volume of load at each layer inside of a stack into the number of devices that are needed to provide that load. So if we suddenly run into a circumstance where we have to increase what's available at, say, the presentation layer, then the AI will automatically create the application and database and other service capacity that's necessary so that there is no cascading bottleneck. Now that's really good for reactive scaling, but the second side is a predictive scaling capacity, which is something I have never seen in any other platform. The predictive scaling capacity is actually the ability for the AI to foresee the load that is going to be generated in the future, and it allows it to be much more dynamic and flexible with the number of services that it has running at any given time. For instance, in typical offices, people come to work at 8 o'clock in the morning and they leave at 5 o'clock at night, and all night long servers are typically doing very little, beyond maybe a backup if that's how your organization is configured. What happens inside of our system is that it can tell at 5 o'clock at night that it's not going to need capacity for 10,000 users for the next few hours, so it's able to scale that capacity back to, say, 1,000 users for what it needs to keep the service operational. But then early in the morning, before it would notice that load is going to be available and will be necessary to keep new employees that are going to come in at 8 o'clock up and functional, the artificial intelligence will significantly increase to the scale that you're going to need. And it does that before that load arrives. Now, because of that cascading bottleneck that exists in existing automatic or dynamic rescaling systems, they're typically tuned so that they won't drop below particular levels, which are fairly high in comparison to the capacity that's necessary at that time. This means the systems are having to keep capacity alive that's not actually currently in use. So because our system can operate predictively, it's able to reduce the overall capacity in times when it's not necessary much further than reactive or dynamic systems can. In addition to being able to scale down the capacity when it's not used, it's also able to scale up capacity much more quickly, which means it doesn't have to wait for users to be experiencing slow behavior inside of your applications before it will outrun and expand what your environment will actually provide as far as capacity.